Hey, welcome to the Chapter 6, Section 2, Execution Control with If, Else, and Boolean Functions presentation lecture. All right, let's start thinking about some more advanced worlds. As we move into Chapter 6 here, we are going to start getting into some more complex code and some more difficult scenarios that need to have code and programming done for. So if we take a look, there's no doubt that you have started to think about building animations like simulations and video games. Chances are that's why most of you decided to take this course to begin with. Now, to build some of these more advanced worlds, you'll need to write code that is going to involve decision making. That's what this is going to do. This is what Section 2 is going to focus on. So different examples of decisions. So for example, in a car race simulation, the driver steers the car around curves and past mile markers. Okay, that's your standard driver. If the car stays on the road, the score is going to increase. If the car goes off the road into the stands, the car crashes. If the driver gets the car over the finish line, the time is posted and the driver wins. If that's the scenario, or if that's the exercise, how do we write the code and make this program a reality? We are going to need to use logical expressions. So a logical expression is a decision that is made based on a current condition. So in this example, a condition is going to be checked in a logical expression, which is going to evaluate whether or not it is true or false. This is the Boolean value. So is the car on the road? Is that true or is that false? The car over the finish line, is that true or is that false? That's the condition that's being tested. So if we break this down a little bit further, in if else, if this condition is true, then do this action. If that condition is false, then do something totally different or do nothing at all. Now in Alice, a logical expression is using the condition of an if-else control structure. We can drag and drop those into our programs anytime needed. Decisions using if-else are used in functions and in methods, so we can use them in both areas. Now an example here is a Boolean function, which is checking a true or false condition. Suppose you are building a simulation system to train an air traffic controller. One of these tasks of an air traffic controller is to be alert for possible collisions in the flight space. So here in this example, you can see we have a helicopter and an airplane. And so how do we build a simulation to show that if these two aircraft collide, we would have a serious problem? All right, so let's take a look. So the storyboard is going to look like this. We are going to take into consideration that one factor in determining whether two aircraft are in danger of colliding is the vertical distance. This is the difference in altitude. So if one is higher than the other, they won't collide. We can write a function that checks the vertical distance against the minimum difference in altitudes and test that. The function returns a true value if they are too close, otherwise it is false. So for example, the storyboard might look like this. Is too close is what we would name it. The parameter is going to be aircraft 1, aircraft 2, and also minimum distance. So 3 parameters that we are going to put in this method. Now, if the vertical distance between aircraft 1 and aircraft 2 is less than the minimum distance, then return a true, and if not, return false. Okay, keep that in mind as we continue with the demo. We are going to take a look at the Chapter 6, Lecture 2, Flight Collision Version 1 demo and see how this is played out. Bring that up real quick. Okay, so here's the demo. Here are the two aircraft in the program like we've seen, and then here is the code. So we're going to have an infinite loop, in which case the helicopter top shaft rotor is going to turn right 2 revolutions. And the biplane propeller is also going to move. And let's go ahead and see what happens. So notice how the airplane goes right through the helicopter. Is that realistic? No. Okay. All right, so what we have illustrated in this example is that a world level relational operator is used to create a Boolean expression as the condition. So the absolute value function is used to make sure that the computed difference in altitude is not a negative number. Okay, the This is mathematical properties now that are coming into your programming code. So it would help if you are familiar with some of these mathematical functions and mathematical operators to be able to write proper code. All right, so if we wanted to take a different approach, what we can do is we can say to avoid a collision, the aircraft that is above the other should move up and the lower craft should move down to avoid colliding. Now the parameters here are now just going to be aircraft 1 and aircraft 2. We can eliminate the minimum distance. So if aircraft 1 is above aircraft 2, then aircraft 1 moves up, aircraft 2 moves down. Otherwise, aircraft 1 move up, aircraft 2 move down. So we're taking condition, determining whether or not it's true or false, and then giving two different actions depending upon what is returned, either a true or false value. All right, so let's take a look at version 2 and see how this is applied. Version 2. Okay, so version 2, here we go. Let's play it. Notice how once we test the condition, the action takes place. So let's take a look and see what it looks like in code. All right, so if the absolute value of aircraft 1, distance above aircraft 2, is less than the minimum distance, so in this situation we actually are still going to be using the minimum distance parameter in this function, that's going to return a true, otherwise it's going to return a false. Okay, so now if we go back to the method, all right, so now if aircraft 1 is above aircraft 2, one aircraft is going to move up, and the other aircraft is going to move down. Okay, so we've set the condition. Here's the condition. World is too close. It's testing a value. It's doing a calculation. Then we can apply that into our method to make sure we do not have a collision. Okay? All right, so that concludes Chapter 6, Section 2 presentation lecture. If you need to, please make sure that you go back and revisit any of the slides if any of the stuff is a little bit confusing and you need to revisit it. Otherwise, I will see you in class tomorrow, or for the I'll see you in the next class period, and what we'll do then is we will go through the Chapter 6, Section 2 in-class example.